Alright, today you're going to have to bear with me a little bit. I just got done eating about 15 pretzels with no water at your pep rally, so this is going to be sweet. But anyway, 3.1 is all about measures of central tendency. All that means is mean, median, and mode. Alright, so when I ever say what is the measure of central tendency, you got to tell me which one is the best. We use the term average to indicate the one number that gives the measure of the center of the population or sample. Okay, so the different averages, or essentially measures of central tendency, we all know as the mode, the median, or the mean, or mean, median, mode, whatever way you want to read it. Now, most of you kind of know this, so I'm going to try to go quick. Okay, obviously the mode, most frequently occurring value in a data set. So if you have 16 students asked which number is occurring the most in this particular instance is 1. All right. Now, the only way you do not have a mode is if every number is only happening one time. So if you had a data set that just happened like 1, 2, 3, and 4, that's it, there would be no mode. Otherwise, you would have a mode. You can have more than one mode, but the number has to be repeated. So in this particular data set, if I had a 2 and a 3, then the 2 and the 3 would be a mode. But since the one that we're talking about right now, 1 definitely occurs the most, so that is the mode. Okay, the next average that we can look at is called the median. You're driving down the road on the interstate or I-29, the middle or whatever on the road it is the median. Same thing here. It's the middle value in an ordered data set. So equal number of data values above and below the median has to happen. It uses the position of the data values rather than the actual values, because sometimes we can have what we call an outlier, and is only slightly affected, rarely affected by extreme data values. Okay? So to find the median, you must order it from smallest to largest. Okay? And then just a few specifics in here. For an odd number, okay, the median is obviously the middle value. Okay? So you can cross things out or whatever. For an even number of numbers, so if there was 10 numbers in your data set, you actually have to take the middle two numbers and you have to find the median of them or the middle of them. You have to find the average of the middle two. Okay? One way to cure this, now this is, some people get a little bit frustrated by this, but the position of your number. Okay? If you take, let's say you had 50 numbers in your data set, you can go 50 plus 1 over 2. That's 51 over 2. That's what, the 25.5. You need to find in between, the position of your median would be exactly between the 25th and 26th number. That's what that means. Okay? So if we only had 10 data sets, all right, 10 plus 1 over 2, okay, your median would be, what do we have, 11 over 2, which is 5.5. Exactly between the 5th and the 6th number would be the position. And then you can obviously figure out that number later. And I'll kind of talk about that as we go. If we have 7 numbers, so an example, okay, we have these numbers, the median. Now some of you are used to just crossing things out. First, second, and your median is 12.1. Okay, so that's the idea. If you want to go back to the position idea, how many do I have? 7 of them, plus 1 over 2. 8 over 2. The fourth number in your data set. 1, 2, 3. Here's the fourth number. That's your winner. That's how you find the median via a position. So you can either cross them out or you can use the position idea. Whatever one works for you. Okay? If they're an even number, so if I threw another one in there, there were 8. Okay, then you go back to cross, 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 cross. We have 2 left. We have to find exactly in the middle of them, essentially the average of those 2. So if you add them up, divide by 2, you end up getting 16.15. Okay? If I use the position idea, going back to that idea before, there were 8 numbers plus 1 over 2. I get 9 over 2, which is 4.5. I need to go exactly between the 4th and 5th number. Hence, right in between or in the middle. Position, so then you would find the average once again. So that's kind of how the position works. It's kind of trivial when it's only 7 or 8, but when you get about 50 or 60 data points, you might want to actually do it that way. Okay? The mean uses all of the data. Okay? You guys know how to calculate mean. You add them up, divide by 2. Now, a few things. If you guys look at your pink formula sheet, okay, the very first thing you see on there is the sample mean. You're going to see this. Oh, that's X bar. I apologize. Okay, sample mean goes, we call this X bar. Okay, the population mean is mu. We call that mu. It's the Greek letter M, even though it looks kind of like a U. Okay, these are notations for the mean. To actually calculate the mean, this is what I was going for on the last page. You're going to see this right here on your pink sheet. So you're always going to have that available. What does this mean? This is the Greek letter sigma. You sum up all of the x's, essentially add them up, and then you divide by the number of numbers you have. You guys all know that, okay? And then a population mean, you'd find it the exact same way, okay? So those are the first two on that formula sheet. So you guys hopefully by now know this. 7 light bulbs are measured to see how long they last. So if you have one and all these other ones, how would you find the mean? You just add them up. So if you add up those numbers, divide by 7, you get 174.43. And you actually write that down. Do you think this is a very good average per se? I hope you say no because of that data value 1. Okay, it just so happened that one light bulb, burnt out quick for whatever reason, so that brought your average down. Okay, so that's one way that it can be affected. Resistant measures, because of that last example, which ones are the best? All right. So resistant measures will not be affected by extreme values as much as they could be. Okay? The mean is not resistant. Okay? Which means extreme values affect it a lot. Okay? So it can be made larger or smaller depending upon one value that you have in there. Okay? The median is resistant because those outliers are gone because you're finding the middle number. So that can be a little bit different. One thing that a lot of statistical things do will throw out outliers. The way they do that is we call it a trimmed mean. Okay? So here's what this means. What's a trim mean? This might be new to you. The only about new thing in this section, period. Okay? The measure of center that is more resistant than the mean but is still sensitive to specific data values. Okay? So what you want to do to trim it, this is no different than trimming your hair. You're going to get rid of some of it, okay? Order the data, and you're going to remove some percentage of the data values from the top and the bottom, okay? The common ones are 5 and 10%, depending upon which ones you want to do, okay? And then you simply collect or compute the mean after you get rid of datas, okay? So let's say I have 20 scores from a history midterm, all right? Somebody, unfortunately, got a 15, 45, 50, all the way up to 100. Okay, I'm hoping you look at that 15 and say, ooh, that could really bring down the average of your class. Okay, so we want to compute the 5%, okay, trimmed mean. So we're going to remove the 50 and the 10. Why is that? What is 5% of 20? Okay, if you guys calculate that, hopefully you're thinking of 1. All right, so then I'm going to get rid of 1 score on each end. That's the idea. Okay. So that's what you want to do. 5% of 20 is 1, so then 1 score from each end. Okay, if it was 10%, you would get rid of 2 scores from each end, depending upon which one you do. So I get rid of these 2, and then you just add up the other 18 scores and divide by 18 instead of adding up all 20 scores and dividing by 20. The trim mean ends up being 72.78. The regular mean was 71.25. Okay, so obviously, I mean, in the grand scheme of things, is 1 percentage point a lot for a class? Well, kinda when you think about it, but that's the idea. That can be a 1% difference, and in statistics, 1% is actually a lot. All right, so that's how you can calculate the trim mean, and you will have to do that. So just think 5% trim mean, multiply the number of data points. So 20 points times maybe a decimal 0.05 is 1 from each end, and that's what you want to kind of look for. Okay, the last thing we're looking at in this section is what we call weighted averages. So you guys know this all the time. Your grade in stats class is a weighted average. It's 70% tests, 20% quizzes, 10% homework, and that's kind of the idea behind it. So you guys know what this is like all the time. It shouldn't be overly new. This formula right here is also on your formula sheet. Is the third one down. Okay, X is just a data value. W is the weight assigned to that value. So just as an example, okay, how about in a pageant? An interview is worth 30% of the score. Appearance is worth 70% of the score. Find the weighted average for a contestant with an interview score of 90 and an appearance score of 80. Okay, so weighted average, you must go the percentage times that score in that category. So the interview is 30 times whatever their interview score is, 90, plus the 70% for their appearance score times 80 is what they actually got. And now on the bottom, this adds up the percentage that you've used in these categories. Most of the time it should add up to 100% because you kind of got to cover all of your bases, and then that will just add them, multiply together and divide by 1, And the contestant then gets an 83% or 83, a score of 83, and then you compare that to the other contestants. So that's kind of an example for it. You have a bunch of homework problems I'd like you to do. Most of them are pretty straightforward. Okay, I've actually shortened it. There's only about 6 of them. Hopefully that you can answer them just fine, and then we will come back to class and shore up any questions you might have. Have a wonderful day.